When given a quadratic that is written in general form, that's y equals ax squared plus bx plus c, the coordinates of the vertex of the parabola are given by the following formula. The vertex can be found at parentheses negative b divided by 2a, comma, f of negative b divided by 2a. In other words, the x-coordinate, to find the x-coordinate of the vertex, we take the opposite of the b coefficient and divide it by twice the a coefficient. And then once we have that x-coordinate, we can plug it into the function to get the corresponding y. Now, one thing to keep in mind here is that if a is greater than 0, that leading coefficient is greater than 0, that means our parabola opens upward. And if the parabola opens upward, that means the vertex is a minimum. If a is less than 0, that tells us that the vertex is a maximum. That would mean that the parabola would be opening downward. So let's do a quick example here. Find the zeros and the vertex of the following parabola. Determine whether the vertex corresponds to a maximum or a minimum. Let's start off with the zeros. Well, how do we find zeros of a quadratic or any function? We set that function equal to 0. Zeros are the same thing as our x-intercepts. So our options for finding zeros of quadratics. Number one, we can factor. All right, what does this quadratic factor into? Well, it factors into a negative 2x minus 5 times an x minus 1, which tells me that my zeros, or my x-intercepts, are going to occur at negative 5 halves and at x equals 1. Now, this is definitely a little bit tricky to factor, so if you're struggling with factoring this, a couple other things that you might try considering, all right, is to take all these terms and bring them to the other side of the equation to make the leading coefficient positive. That can help sometimes. And also, if you're still not getting the factoring, your other option is to use the quadratic formula. The quadratic formula will get you the exact same answers. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Right? So if factoring is not working out, don't be afraid to give the quadratic formula a shot. All right, let's see if we can't find the vertex using our new vertex formula here. All right, the vertex is negative b over 2a, comma, f of negative b over 2a. Well, the opposite of the b constant, that's going to be a positive 3, divided by 2 times a. That would give me a negative 4. So our vertex will be located at 3 divided by negative 4, that's negative 3/4, comma, f of negative 3/4. Well, to find this y-coordinate, what we have to do is evaluate f of negative 3/4. That means we need to plug in 3/4 into our function to find the corresponding y. Again, if we have an x-coordinate, to get the corresponding y, we have to plug it in. That means f of negative 3/4 is equal to negative 2 times negative 3/4 squared minus 3 times negative 3/4 plus 5. So, how do we square a fraction? Well, to square a fraction, we simply square the numerator and the denominator. Notice because this is negative, that when we square it, it will become a positive. This will be a positive 9 over 16. All right, and then we have to multiply these two fractions. When I multiply fractions, we just go straight across. So this gives me a plus 9 over 4. I have negative 2 times 9 over 16 plus 9 over 4 plus 5. All right, we can do out a little bit more algebra. All right, check your algebra. Make sure you know how to work with fractions. Okay, in order to add fractions, we're going to have to get a common denominator. All right, practice it out. You should end up with 49 divided by 8. All right, make sure you know how to get that. If you're having questions on that, make sure you ask. So our vertex is negative 3/4, comma, 49 divided by 8. Now, is the vertex a maximum or a minimum? Well, we look at the leading coefficient. We notice that a is a negative 2. All right, that means that our parabola is going to open downward. And if the parabola opens downward, that tells us that our vertex must be a maximum. All right, it also makes sense because notice that this point, our vertex, is located above the x-axis. All right, it's above the x-axis, and these would be my zeros, which means that it would have to go down. Let's see if we can't apply this to a little word problem now. The path of a punted football is modeled by the function y equals negative 1 divided by 100x squared plus 2x plus 3 halves, where y represents the height of the ball in feet and x represents the horizontal distance from the point at which the ball was punted. How high was the ball when it was punted? What this is referring to is its initial height. So when it was punted, the value of x that represents our horizontal distance would actually be 0. So this is asking us to find the height when x is equal to 0. Notice that plugging in 0 for x into our function gives us out 3 over 2. And y is measured in feet. Therefore, our answer is 3 over 2 feet, or 1.5 feet. This is punted from 1.5 feet high. What is the maximum height of the punt? Well, how are we going to find the maximum height of the punt? If you think about the trajectory of this object, where does its maximum occur? This is a parabola, and the parabola opens downward. It opens downward, right? So the maximum height of the punt occurs at the vertex of the parabola. Yes, we need to find the vertex, right? And we can do this using our vertex formula, right? The vertex formula is negative b over 2a, comma, f of negative b over 2a. So to find the x-coordinate, we take negative b, the opposite of b, and divide it by 2a. The opposite of b would be a negative 2. Divided by 2 times a would be divided by negative 1 divided by 50. Now, remember that dividing by a fraction is the same as multiplying by the reciprocal of that fraction. Instead of dividing by negative 1 over 50, we can multiply by negative 50 over 1, which gives us 100. Okay, x is 100 at our vertex. Is that the maximum height? No. Think about what x represents. X represents the horizontal distance from the point at which the ball was punted. So this is not our answer. This is where the vertex is occurring, where it reaches its maximum height, the x value. But to find the maximum height, we need to find the corresponding y, right? Y represents the height of the ball. So to do that, we need to evaluate f of 100. That means we just plug in 100 for x. This is negative 1 over 100 times 100 squared plus 2 times 100 plus 3 halves. Well, notice I've got 100 squared divided by 100. That just leaves me with 100 times negative 1 would give me a negative 100 plus 200 plus 3 halves. So 103 halves, or 101.5 feet, would be the maximum height of the punt.